To finish off with Appendix C last time, so we'll finish it off now. Let's see. We had looked at the observation ROV here. We had looked at the construction ROV, and we also entered the Just Design webpage and just looked a little bit at how you figure out the data sheets and everything from a company's webpage. So the next one we'll look at is an AUV, an autonomous underwater vehicle. So this is the Hugin vehicle, which was the first one made by the Kongsberg company. So they've recently made another one named Munin. So these are two ravens from Norse mythology. So Hugin and Munin. So that's probably why they chose those names, since there are exactly two of them. So the first one, I think it's 10 or 12 years old now. So it's quite a bit old, and it was a research project together with the Navy. So the Navy Research Institute. They did this together with Kongsberg Simrad, I think their name is, in the company. So they created this first AUV, and it was fairly expensive, and mostly because it was expensive technology, expensive batteries, and all of that. But this new one, the Munin one that they've just created, is quite a lot more cheaper. So I think the price range I saw was 1.5 to 2 million Norwegian kroner. So it's not that bad, considering it's an autonomous underwater vehicle. It's more expensive than a regular ROV, but still it's going to require less operational costs with regards to a surface vessel. So that in the overall scheme you will probably save money in using it. And also, it's supposed to be able to mobilize very quickly, so you don't need to have it. Strapped onto one vessel, and that vessel has to manage to make its way to wherever it's going to do the operation, because it's a modular system in containers. So they have the control container and everything in one, and then I think they have the launch and recovery system, along with the workshop part and the AUV itself in another container. So I believe it's only 2 containers that they need. So they just need to ship 2 containers to wherever it is in the world that this needs to be done, and then they can launch from the container. So the container just needs to be placed at the back end of the ship, all the way to the back, maybe a little bit across the end of it, so that it can launch directly from the container. So you don't really need to have any permanent installations on your ships in order to do this. So what they're hoping is that it's going to overall make it a lot cheaper to use this kind of AUV, that companies can have 1 or 2 in their central warehousing. And then when they need to use it somewhere in the world to survey a pipeline or something, they can just ship the 2 containers off to that part of the world, and then they can employ a fairly cheap vessel to do the launching and recovering of the AUV. So I think it has potential to be very potent technology to be used. So we'll see how it goes. It's fairly new, so I think it's just 1 year old or something. So we won't really know how effective it's going to be until it's been around a couple of years, and several companies have actually tested it out and seen if it delivers on its promises. But the surveying technology used in it is basically the same as in a regular survey ROV, so that it's going to give you the same kind of data that you're going to get from a regular one. Basically a map of the ocean floor and proper inspections of the pipelines with the different tools it has on board. Of course, it also needs a couple of extra tools. So it's going to need quite good navigation, because this one needs to navigate all on its own. So it needs better navigation than a regular ROV, because the regular ROV is connected to the surface vessel with a cable. And using hydroacoustic signals, it always knows where it's positioned compared to the vessel. And then the vessel itself has a GPS location and everything it needs to know exactly where the vessel is. So it's a lot easier for a regular ROV to navigate that way. While the AUV, it needs to bring everything on its own. And of course, you can't use GPS on the water either. GPS is also wireless signals, and mostly nothing reaches past water. So it needs to figure out where it is with better navigation systems, more suited for total submersion of the system. So more akin to what they are using in actual submarines when they are moving those about. You have a wide range of sensors which you can put on it. Basically, depending a bit on what kind of work you're going to do. So of course, the more sensors you put on your AUV, the more energy it's going to require, so less operating time it's going to have on its battery charge. So if you can equip it with just the sensors you need and nothing else, then that's going to help on your operation time, because then it can actually work for a longer period of time on what energy it has. And it also has very fast battery charging. So this one has lithium polymer battery modules. I think the new one has lithium ion battery modules, the same that is in any smartphone or any electrical car, basically. So so long as it's not a Samsung Note 7, because then it's going to explode instead. I actually read a little bit about that, and they've botched up the battery design on it. That's why they start burning and exploding. With the lithium batteries, or basically any battery like that, you have an anode and a cathode, and you're going to have electrical potential going between them. So one of them is positive and the other is negative. And you will have electrical charge passing between these. But in order to avoid a short circuit, you want them to be as close as possible to each other in order to gain as much efficiency as possible. But if they're actually touching each other, you get a short circuit. So what you do is you put a very thin membrane between them. So that you actually just putting almost like papers on top of each other. So you're making sort of a sandwich of all of these parts. And what I've understood that they did with the Samsung is that it's basically too thin. So they're getting shortcuts through the membrane. So that's why they catch fire every now and then. So if you get a little bit wrong operating conditions for the battery, then you get a short circuit, and then if you get a short circuit, you get massive amounts of energy passing through there. And if you have massive amounts of energy in a short period of time, you get a lot of heat, and then it starts burning. So it's basically it's the same thing that would happen if you do a regular 12-volt car battery, and you put a wrench across the poles of it. The wrench is going to go red hot, and it's going to explode. Because it's basically the same. It's just whenever you have a short circuit on a battery that is of a fair enough size, it's going to create a lot of heat. Even on the small AA or AAA batteries, if you short circuit those, they're going to be quite warm, so they're going to be very hot to the touch. So it's dangerous stuff. Hopefully that won't happen with the AUVs while they're out there working. We wouldn't want that. At least they won't catch fire for a long period of time, because they'll be submerged anyway. And as we can see here, it says that it has a launch and recovery system with 15 years of field experience, because this is a bit different launch and recovery system, what they use, because they're putting it at the back end of the vessel. So if you're just putting up a regular vessel here, they're putting the container at the back end here. So the AUV is inside the container. And what they're just basically doing, they're opening up the hatches, and then they're extending a ramp that's going into the water. I think we saw it briefly in the clip that we were looking at. The AUV is going to move down the ramp when they're launching it. So they're basically just letting it slide right into the water. And when it's coming back up, I believe they have a, at least on the new one, I'm not sure how it is on the old one, but on the new one, they have a hinge system on this slide part, where they can make it a bit more flat at the beginning. So the AUV moves up here, places itself on the flat parts, more flat parts, and then they connect wiring to it, and then they pull it the rest of the way up. So once they've connected the wires to it, they're going to lower this part again down to, so that they're basically just pulling it straight up. So that's a so that's the basic system they have, and that's also why they can mobilize it pretty quickly, because you just need to move these two containers off to wherever it is, and you just need a regular anchor handling vessel, so you don't need anything special in order to do it. So it's a very cool system. I think I have the link to their webpage here also. Let's see. I'm not sure if that was the direct one. I think it was here. As you can see, they have a lot of different things on offer. There it is, autonomous underwater vehicle. So they got other kinds also, which are basically based on the same principles as the Hugin and Munin, but they're cheaper versions, if I recall correctly here. We can go to the Munin, which is the newest one, where you can get to see 3D models, some images, all of the data specs for it. We have different tabs to enter here to see different parts of it, the YouTube clip that we watched last time. So you can find quite a lot by just going to the different, that was the last one on that one, okay. So you can find quite a lot of information just by going directly to the manufacturer and supplier of equipment like that. So the next one is not Appendix A. I've forgotten to switch that one. This is Appendix D, I think. So here we're going to look a bit more at different equipment that's placed on, especially on work ROVs. So it's a bit difficult to show the equipment on the survey ROVs because they're mainly sensors, so it's hard to sort of grasp what this box is actually doing because it's not quite that obvious with it. But what we have is here's a manipulator for an ROV, and this part here is actually the controller that the pilot uses. So you can see it has basically a mock-up of the manipulator arm, and what happens is that the ROV pilot, he grabs a hold of the tip there and he moves the tip over to where he wants it to be on the camera. And then he's watching the camera as he's moving the tip, and the actual manipulator down on the ROV mimics the motion of what's happening here. So it basically has sensors on all of the joints telling this one how many degrees of movement it's going to put in. So it's a pretty advanced system. I think some of the newer ROVs have even more advanced systems where you're looking at more of the gaming console aspect almost on it, so that it looks even more like a game. This is pretty obvious that you're moving a manipulator arm, but some of newer systems are very. It's just a joypad basically, where you're just like playing your Xbox or PlayStation almost. So it's pretty cool, and you see quite a lot of those systems, especially on smaller ROVs where they're maybe being developed by a new company or something like that. They might actually use an Xbox controller or a PlayStation controller, and they modify the controller to work with their ROV. So they're actually using equipment like that. And especially for the younger generations, those who were born a bit after I was born, at least, so in their 20s or late teens, gaming is very, very common. So it's just a part of everyday life to play games, and I think that the training part of a new ROV pilot is going to become much easier if they sort of build a control system so that it resembles a game a lot more. So it's going to be a lot easier for new pilots to get a handle on the systems. This picture is fairly old, as you can see from the quality, and this is from FMC Technologies, which own something that is named Schilling Robotics. And this is a very new, completely new manipulator arm. This one isn't in your compendium. I've gone to this web page and I've gotten it there. So that's just to get to show, because I felt the quality was so poor on the copies in the compendium that if I was going to blow them up on the screen here, basically didn't show anything. It was impossible to read it. So then I just went, the original one here is, I can't remember if that one is actually a Schilling one, but it's basically the same functions that we have. So we can just as well look at a completely new one. In this case, they are profiling it as having an extraordinary lift to weight ratio, which means that it can lift a lot more than what it weighs. So the ratio between its own weight and the strength of what the strength it has to lift stuff is pretty high. Which means that, if I know Schilling correctly, it is probably made out of titanium, so that the weight is being kept low and the strength is being kept high. But the price is also being kept high, since it's titanium it's made of. So it also has what they're calling premium dexterity, which allows for effective positioning while grasping wellheads, panels, or tools. So I'm guessing that means basically that the joints of this manipulator have extra movement or something like that. It's because that's basically what the dexterity is. You can move quickly and accurately over a wide motion range. So that's probably it for it. And that is something that's being continuously improved on with this kind of technology. It is basically the small motors that are running the joints and moving this. It's constantly getting better. Just looking at like in the car industry, in the factories of the car industry, almost everything is being done by basically manipulators that like this. It's huge robot arms that are doing all of the assembling of the cars mostly, and all of the spray painting and stuff like that, being done by huge robot arms. And of course, all of the technology advancements that they are making in their huge industry, it sort of trickles down and gets into this industry, where they can see that, well, they've developed a new kind of servo engine to use inside the shoulder joint down here. So we can start using this one also. It's going to be more effective than the one we already have. Maybe it's more compact, so it weighs less. So there's just constant changes at all times. And this one has a long reach and a high degree of agility. So it gets a large operating envelope, is what they're calling it. And that is the one, I'm not sure if I had shown it. No, I hadn't shown it here. So we have to go into the web page afterwards to look at it. So I'll explain what a large operating envelope is later on. And it has a lot of common parts, which is always a good thing when you're designing something, especially when you're working as a mechanical engineer and you're designing equipment. The more common parts that you can use, the better it's going to be, because if lots of equipment use the same parts, it's a lot easier for the warehousing to have all of the parts in stock, because they don't need to have a separate set of spare parts for every single tool that's going to be used. They can use the same pool of spare parts for most of the tools, which means that not all of the tools are going to need spare parts at the same time, so they don't need to have one set of spare parts for every tool that they have. So if you have like 100, 200 tools for ROVs in your stock, you don't need to have 100 to 200 sets of spare parts. You just need to have maybe 20, 30 sets, just so that you have, in case a lot of the equipment needs servicing and changing of parts at the same time. But you'd be basically a statistical anomaly if all of your tools ended up needing spare parts at the same time. That just wouldn't happen. So that using common parts is very good. And this one, built for durability and reliability in harsh subsea environments. That's a given, at least if they have used, it looks like they've used titanium. So and if they've used titanium, it's one of the best things that you can use in subsea environments, since it doesn't really corrode at all if you're using only titanium. As soon as you connect it to something else electrically, then you're going to have the whole sacrificial anode stuff going on, so that you can end up getting corrosion, not necessarily on the titanium itself, but you can have very speedy corrosion on whatever else you've connected to the titanium, and that's not going to be good. So when you're using titanium, it's important to sort of separate it from the rest of the vehicle. And this one can work down to 6,500 meters of seawater, so it's got a pretty decent depth rating there. I don't think they actually do work that deep, not even outside of Brazil. I know they've been down to 4,000 something in the Mexico Gulf and outside of Brazil. So, but I don't think they've been down to 6,500. But again, you have research vessels that are moving down to those depths to check out stuff, so they're going to need equipment like this also. So let's have a look at the web page. If I remember correctly, it's going directly to the data sheet on this one. No, it wasn't directly to it, but this was the Atlas 7R, I think it was. There we have the data sheet. So here you can see different options for the claws. So there are quite a lot of different options you can have. So these claws like this are more, so you can see they're called a gripper option in that one. These one are more designed to have two parallel surfaces. So when you have them extended, they're going to be this part here. And when you close them, they're the part protruding here. So you can see that this surface and this surface is parallel when it's open, and it's also parallel when it's closed. So it's getting closed directly onto it, which means that you get a lot more of the basically that's as close as you can get to having a finger feeling of what you're doing. So you can have a very fine touch with it. So you can operate smaller details and do them in a lot more, what are we going to call it, a softer way, so that you don't destroy anything with it. So that's the main option for that one. It's doing the more finer detail work with it. Then you have different kinds of claws with intermeshing fingers. So in this one you have open claws, and once you close it, they're going to intermesh, so that they're going to sort of grab around it, and they're going to make sure that it's impossible for anything to escape from the grip once they've closed it down. And there are different sizes of them. You see this one is set at 7.8 inches, and this one at 11.5 inches. So it's you can have pretty large claws on them. And the claws are used mainly for really rough operations. So just grabbing and lifting and stuff like that. Sometimes you can use them also to rotate valves because they've got handles that are fitted for the claws. So typically, if you have an ROV that's going to do some very fine work, you would have this kind of gripper on the main arm that you're going to do the work with, the one that has the most functions on it, so that it has quite a lot of joints and can move around pretty well. And then for the other arm, which has less joints and is basically just used for holding the ROV steady, you would use one of the claws instead. So we'll just grip a hold of something with the claws and just stay there, and then use this one for the fine details. And we'll just scroll a bit down here. And here we are looking at the manipulator arm from the side. So this is where it's mounted to the ROV, and it's been extended straight in a horizontal line. And the stuff that they've shown here, this is the envelope of motion for it, basically. So from the side view. The envelope of motion will, of course, be the entire three-dimensional area where you can operate with your claws. So it's basically all of the area where the claw can move and do something. So when we're looking at it from the side, it's going to be within this area. And you can see the different joints of the manipulator is what rules the outlines of this area, basically. So where, how far it can extend in with each joint before it has to stop and just rotate instead. And it's the same if we go down here, so we can see it from the top. So it's from the top, so the mounting point on the RV would be here. And here we can see it going sideways for a certain amount of degrees. And it can reach all the way in there, or it can reach all the way out there, depending on how it's going to fold up its joints from the side view here. Yeah. Yeah. So here we just see a typical outline drawing, just to reference it back to our CAD sessions. In an outline drawing, you're finished with your assembly. You've created all of your parts, you've done your assembly, you've created your assembly drawing, but then sometimes you have an outline drawing, which typically go on a data sheet or just directly to customers that are interested in your product. And the main idea is to give the overall dimensions. So once it's been folded up like this, which is the resting position when it's mounted on the ROV, it's going to extend 834 millimeters from the back and to the front here. And it's going to be, the main part that is mounted on the ROV is going to be 296 millimeters high. And then we have all the way up to, from the bottom down here and to the top points, we have approximately 880 something millimeters to the top points, which is very, very useful with regards to transportation and also having it fit inside an ROV. And because these guys from Schilling, they are creating their own ROVs also, but they're also selling individual manipulators, so that I think Just Design here buys their manipulators from Schilling. So I'm pretty sure they use Schilling manipulators, so that it's quite a good deal for them. They're creating all of these manipulators and then they're just selling them off. But of course, whoever is designing an ROV somewhere else in the world and is going to put this manipulator into place, they need to know the basic dimensions of the resting position, and they're going to need to know that envelope of motion, just to know how much area do I need to keep open in front of my ROV, so to make sure that the manipulator arm isn't going to crash into something. So you wouldn't want to put a, let's see, looking at it from the side here, you wouldn't want to have your camera mounted somewhere up here, because then if you're extending your manipulator too far up, you're going to smash it into the camera and break it. So it's nice to know all of these these dimensions when you're creating something. So then we'll continue on with the other tools for an ROV. So here we have a wire cutter. There's a wide range of different designs on these. Emenco has tried to make some also. I don't think they've gotten them fully successful yet. They ended up becoming a cutting tool for smaller wires than what was originally intended. Basically just because it's not always that easy to know how things are going to behave when you sit there and you're designing a tool like this, which is basically you have a housing that's going to keep the steel wire in place, and then you're going to have a cutting blade that's basically just going to be forced into the steel wire, and it's just going to act like a scissor and just going to cut straight through it like a knife, is the idea with these. But one thing that happens once you have these braided steel wires is that as soon as the top parts, so if we do a cross section across the steel wire, it basically looks like, depending on the size of the wire, it is basically just loads of thinner steel wires that are braided together. And the problem is, as soon as you're trying to cut this, if you're coming in here with a sharp blade, you're forcing it into the wire, then of course the top ones here are going to snap first. But as soon as they snap, the whole wire is going to start behaving differently, because now it suddenly has only this part that is its strength. And then when you snap the next layer, then it's going to behave even more differently. So it's a very, very time-consuming process to design something like this. I've been slightly on the edges of the design process that Emenco was working on here, and I got to see all of the problems that this can end up with. So it's like loads of things that you didn't think were ever going to be a problem ends up becoming a problem once you've manufactured your prototype and is actually testing it. And then it's sort of starting to get a bit late, because if you then have to do a lot of changes, you have to go back to your drawing board, you have to start drawing your design all over again, trying to take all of these things into account. So then you create another prototype, you get into the testing, and then you get even more problems that you didn't notice the first time around. They weren't, because you had a different set of problems on the first go. These new problems didn't show on the first go, so you never got that far. But now you have more problems, and now you have to do the design over again and try to figure out how to do it. So what I think Emenco ended up doing with regards to the economical situation in the market and everything, they figured out that, well, using a lot of money in developing a new tool like this, when there are already functioning tools on the market, that's not a good idea for us right now. We can't really afford that. So we're just going to keep this one for now as it is, because it can't cut the thick steel wires that we wanted it to cut. It can cut thinner ones, and it can also cut cables, so electrical cables and stuff like that. So that's going to work, and rubber tubing and stuff like that. So it still has a use. So we're still going to offer the tool up for use, at least the prototypes. I think they have them for rent, so that companies can just rent them, because that was one of the first things that happened once the oil market started going downwards. It was that we're not buying equipment anymore, we're just renting it. so that instead of doing what Statoil and Technip and Aker and everyone had always been doing, was buying a separate set of tools and equipment for every project that they were doing, for every large project, they were now instead starting to look around at the other projects that they had. maybe they have some tools that we can borrow from them. And if no one had the tools that they needed, they were going to rental companies instead and renting it. So just using it for the operation and then delivering it back to the rental company. So sort of became a whole different situation. The way this one works is that it is hydraulic. So it has a hydraulic cylinder in here, and inside the housing it has this sharp blade that's going to cut into the steel wire, and you can see it a bit better in there. There are so many different designs. The one that I was working with briefly in Emenco with looked more like this one, where it was open on the side so that you could just put it onto the wire and then you could cut. You see, like this one, it looks more like a shackle almost. So it has a housing where you trap the steel wire inside, and then you have some sort of steel bar that you put across. Instead of having this lip down here, you have that steel bar which you slide in, trapping the steel wire in place. So we're going to see that clip before we have a break. So the guys creating this one are called WebTool, and they've got very good wire cuttings. So with their design there, they had full control on this steel wire. But you can see it's like jumping and jerking around, and that's every time one of the strands are being snapped. That's when it's sort of doing all of it, and that's all of the noise also. And then it gets to a point where the remaining strands just they can't handle the pressure anymore, so they just snap also. So it's a very and you can see the diameter. Briefly see the diameter here, 150 millimeters. So that's pretty heavy diameter for the steel wire to be. So we'll do a break before we continue to the next slide here. So we'll go back to that one. When we did the testings of the wire cutter at Imenco, it was pretty, as they would say in California, it was pretty gnarly. There were splinters of this steel wire that were just flying everywhere, and fortunately we were sort of prepared for this, so we were all standing behind this thick plexiglass wall just to protect ourselves. But that was pretty. Some of the steel fragments actually slammed into the plexiglass wall, and I could see the whole wall was just flipping towards me. So it was there's quite a lot of energy going on in there. And as John asked in the break, there is of course a hydraulic cylinder in this one. For the really small ones, it is possible to run them electronically. But I don't think anyone has actually created a tool for an ROV that's going to be run with electrical power that way. But for the large ones, just getting the amount of force that you need in order to push the blade through all of the steel, you're going to need powerful hydraulics for it. So in the mid-range size of these cutters, some of them can be run by the hydraulic system in the ROV. It depends a bit on how powerful that hydraulic system is, how much pressure it has, and has the maximum operating pressure. If the ROV isn't powerful enough to run it, then the tool has to be connected by basically a long hose up to the surface vessel, and it has to have its hydraulic energy delivered from the surface vessel instead. So it depends a bit on what kind of what kind of size it is and what kind of ROV it is. Then we have cutting tools. So this cutter is basically like a regular grinder that you would use in a workshop. The grinders, they're the one tool that would never, ever have been invented nowadays. With all of the health, security, and environment stuff going on, no one would ever invent a grinder. But because they were invented long, long ago, they're still in use. So they're one of the most dangerous tools that you can have around in a workshop. And basically, it's because you're spinning a cutting disc, whether it is a fiber cutting disc or it might have a diamond edge to cut other stuff, or it might have different kinds of shapes and types of it, depending on what you are going to cut. If it's concrete you're going to cut, you will have a concrete disc to use on it. Not a disc made from concrete, but a concrete cutting disc. And the disc is open, so it's just going to spin around there, and if you touch it, and that's like 2,500 RPMs. So whatever touches it, it's going to cut it. And if you don't touch the edge of it, if you touch the flat of it, it's going to grind you. So no matter what you do, it's a problem. I actually have a scar on one of my fingers from a grinder. So then I had a grinding disc on it, so it wasn't a cutting disc. So thankfully, it just basically shaved off a lot of my skin and top layer of flesh on my finger. So it went straight through my. I had one of these. I had a pair of these Kevlar gloves that you're supposed to use when you're handling dangerous equipment, but it has Kevlar on your palm. It doesn't have Kevlar on the top side. There it's just thick fabric, so it just went straight through the fabric and into my hand. Thankfully, I felt it quickly enough that I got my hand out of the way, but it was pretty deep, so it bled quite a lot. But that's how it goes if you're not careful when you're working with these. And that's basically what this one is. So it's a grinder like that the ROV can operate. It also has a mouth here where it can grip a hold of, for an example, if it's going to cut through a pipe up to a certain dimension, you can insert the tool onto the pipe. So you put it over the pipe, and then you lock it in place by flipping this one over and locking it in. And then it's going to stay there on the pipe, and you have a hydraulic cylinder here that's going to push on the you basically have a rotating arm that the disc is connected to, and then you have the cylinder here, which is going to push on the rotating arm so that it's going to basically just rotate the entire spinning disc onto the pipe, and then it's going to cut through the pipe. But if you wanted to, you could also just hold it in your hand and just hold it in the manipulator claw and just push it into whatever it is you're going to cut. And I know that's been done sometimes in difficult to reach locations where you can't manage to lock it onto whatever it is, whatever pipe it is that you're going to cut. Then they've just held onto something with the ROV, and then they've held onto that one, and they've just tried to slowly push it in. The problem there is that just make some space here. So when you are cutting into a material, you're basically creating a groove like this, especially with a cutting disc like that one. If you were cutting with a circular saw instead, with a circular saw you would get a rectangular groove, because with the circular saw you've got the teeth on the saw, and they have a 90-degree edge, so that they're going to create a 90-degree edge on the cut. But on a disc like this, it's basically just a disc that is it's basically just spinning quickly enough to erode away the material. So the disc is going to be misshapen as it goes along, so it's going to be more and more curved like this the more you cut with it. And the problem is then, if you have an ROV that's holding onto something and then moving this tool with its other manipulator into here, if your disc that is in here suddenly gets at an angle like this, because the ROV suddenly got a jerk or something, something happened with the manipulator with the ROV so that it moved a little bit more than it should, then you're going to put a lot of strain on the side of the disc, and these discs are very brittle, so that if you put too much strain on it, that's going to happen if you're doing it by hand also with a regular grinder, and you sort of push too much on the sides of the disc, it's going to shatter, and when it shatters, you've got pieces of disc flying everywhere. So it's not that good to it's not that good for the operation to be doing this sort of by hand with the ROV manipulator, because it's very risky to do it. You might have to basically pull everything topside again and exchange for another disc or something like that to be able to finish off the cut. Most likely you won't damage anything if you break a disc down there, because everything around you is basically steel. Maybe you're really unlucky and one of the fragments hits the camera port on your ROV, so suddenly you've blinded your ROV also. So that might be a problem, but yeah.
Isn't it possible to lock the ROV onto the pipe as well? So if there's a jerk.
Yeah, that is the case where I've seen. I haven't seen any video of it, but I've seen photographs where they've done still images from the camera, where the ROV is actually handling a cutter, not this particular cutter type, but a similar cutter. So the same principle, but a different supplier. So I can guarantee you that in the user manual for cutters like this, it says that under no circumstances are you going to cut with it without having it locked onto whatever it's going to cut, because it is dangerous. But again, if you're in an operation and it's a very difficult to get to area, you really have to make this cut, then you're going to try whatever you have to try in order to make it. So there's a saying here in Norway that there's a lot of cowboys working out on the offshore rigs because they can be liable to try out anything to get the work done sometimes. So long as the ROV pilot figures that he can do this, and his superiors give the okay to try it, then they're going to try it, because if he can do it successfully, it's going to take a lot less time than getting some specialized cutting equipment in there. There might even be that there isn't any specialized cutting equipment existing that can do the job, that you actually have to do it somehow with something else that's not meant for that particular task. So that's that kind of cutting tool, the cutting discs. Then you have other tools which use circular saw blades, and this is one of the Emenco tools, also on this one. So this is from the FAT testing of the tool. I was actually in on most of the design on this one, so I've done all of the hydraulic layout on it, and basically done most of the assembly, the physical assembly in the workshop, along with the mechanics and technicians, and put it together, and also joined a lot of the tests that they've done. So it's a really cool tool, because it has these claws over on the sides, and they're connected. Each of these sides have their own hydraulic cylinder, which means that the hydraulic cylinders on the sides, they're going to push on the claws, and then if you have put it into a steel pipe, I think it's up to 215 millimeters diameter, if I remember correctly, for a steel pipe. It can be a solid pipe, or it can be a hollow pipe. Doesn't really matter. It's going to cut through it anyway. But then these claws will grab onto the pipe, and it will hold it into place. And then it also has some counter parts on the inside here, which are centering the pipe. So it's going to end up in the middle. The ROV can lift this one. It's not really all that big. It's about as long as this desk and a little bit wider. And not as tall as the desk either. So it's not all that much. Weight-wise, I wouldn't be able to lift it, but I was able to flip it, so that I could grab a hold of the claws, and I could flip it up so that it was vertical when I was working on it. So it's not all that heavy, even though it's made out of quite a lot of steel and aluminium. There are some pressure gauges up top here, just to show the different operating pressures. There is also a manual meter slide here, which is connected to the cylinder that is pushing the saw blade forwards, so that it's going to show the position of the saw blade, how many centimeters you've cut into the tool. I'm also saying centimeters because we could have put it up in millimeters, wouldn't have been a problem, but considering that you're going to be holding on to this with an ROV and looking at it with a camera from a bit of a distance, it would be very unlikely that they would be able to actually read off whole millimeters. So it's put in centimeters instead, just to have a fair idea of how far you've cut. It has hydraulic stabs on the back there, 2 of them. So there's one for the hydraulic motor that is spinning the saw blade, and then the other one is for the cylinders. So we are running the cylinders on a separate hydraulic stab. And these stabs are basically just quick connections. So the stabs will have connectors that are screwed onto the hydraulic supply on the ROV. So they will be directly connected to the ROV. And then when the ROV needs to use the tool, it's going to fly over to it, pick it up, and then it's going to put those stabs into the tool, so that it has connection with it, and then it can run the tool. One interesting thing with the cylinder that is pushing the saw blade forwards, it has a pressure reducing valve, so that it is set up to have a maximum of 20 kilograms of pressure that it's putting on, so that, because if you force the blade forward with too much pressure, you're just going to jam it, so that it's not going to work properly. So you have to have you have to have some pressure in order to force the saw blade forwards, but you can't have too much, so that you have we restricted it to 20 kilograms, and that was just a gut feeling that we had. So we were sort of feeling our way around with pushing on different kinds of weights, and then we were trying out the circular saw that was in the workshop, and then we were just pushing wood into it and just testing, and then pushing steel into it and seeing how it behaved differently as we were pushing. So then we figured out that somewhere between 15 and 25 kilograms that would be fair enough in order to have a fair progress on it when it was cutting. Sadly enough, I didn't get to see it finished, so that it got this far. We were rushing it in order to get it done for a specific operation that it was going to do, where it was going to cut really huge chains. Basically, it was impossible to cut both chains at once, so it was for an anchor chain that was so large that we had to have just one side of the chain in there. So that's how large the chain was. What no one had been told to begin with, well, we had probably been told it, but we weren't aware that it was going to be a factor, was that this huge chain was made out of a fairly recently developed material, which has quite a lot of internal strain in it. So a problem we ended up with was that we got halfway through the material, and then we just stopped. The blade was spinning, but it wasn't moving forwards. So we were just like, well, what's going on here? Then we tried pulling the blade back, and it wouldn't go back either. So it was completely stuck, even though it was spinning. So it wouldn't go back or forwards, because on a blade like that, you have the steel of the blade itself, but then you have at the end where the teeth are, it's a bit wider. So that it creates a wider groove than the blade itself, so that you have a movement for the blades to move a little bit. And our problem was that when we were cutting into the material, so we were getting into the material, creating this groove, but there was so much internal strain inside the material that it started closing, so that it ended up with pressing on the sides of our blade here. So that's why we couldn't get the blade out, because it was stuck with the teeth all the way in there. It couldn't get further on because it got so much pressure on the sides of the blade that it wasn't a problem making it rotate, but you couldn't push it forward either, because you needed more than 20 kilograms to push it forward. And when we tried to increase the pressure, so we regulated the pressure reducing valve that we were using. So when we tried that, it just ended up choking the motor. So then it didn't manage to rotate it anymore. So then it was completely stuck. So we ruined a couple of saw blades on that way. We basically had to cut the saw blades, make a cut in the saw blades in order to be able to get it out. So that was a huge problem there. Fortunately, the tool was going to be used as a last resort in a anchoring operation, where it was supposed to, if all else fails, then they were going to cut the anchoring chain. But in this particular case, the lower part of the chain, where the chain meets the anchor, there was fiber wire instead. So it was basically a very thick fiber rope. So the rope was so thick that it just barely, it didn't actually fit within the pipe dimension that we had set. But since it's a rope, it can be slightly compressed by the claws, so that our saw would actually manage to saw almost all the way through. And anyways, if we were going to saw on it, this entire chain would be under strain, so it would be pulling on the strain, pulling on the chain, and also on the fiber rope. So with up to 20 tons. So we didn't really need to cut all the way through, because it was going to snap at the end anyway. They didn't need to use it at all in that operation, but we did a test with the fiber rope, and it cut cleanly through the fiber rope without any problem. So that wasn't a problem there. And then after I had been sent on a leave of absence, then they did this test with a smaller chain, and then it went straight through. And that was a more regular material also, so that they figured out that it can be used for regular chains, but it can't be used for these heavy-duty, huge chains for it. But that was a pretty unexpected thing with the blocking of the blade here on this one. So no one had really thought that was going to be a problem when we were designing it. So, but that's the kind of stuff you learn when you're working on it. And all of the red stuff here, that's buoyancy elements. So it's I was the one who cut them into shape to get them in there, and they are basically they feel almost like wood when you're handling them, approximately the weight of a wood block, a dry wood block, basically, and when you're handling them. But when you're starting to cut them, you really need to use breathing protection gear and stuff like that, and loads of masks and everything, because what they are basically comprised of is very tiny glass orbs, which are filled with air. And all of this has been compressed together into a sort of fiber stuff. So that's why it's so light, because there's a lot of glass bubbles inside it that are filled with air. But you really don't want to, when you start cutting in it, you really don't want these glass bubbles to end up in your lungs and stuff like that, because it's not exactly toxic, but it's not health-inducing either. So you have to be very careful when we are working with it. So, but that was a very, very nice development project to be in, because I think that was the one project where I learned the most of all of the projects that I was a part of in Enco. So, and it's really nice to see that they've actually got it working properly with a regular chain, because we were, when we couldn't cut the huge chain, then we were afraid that maybe there was something more wrong with the design, that we weren't going to be able to cut other chains either. But right then we had to send it off to be available for cutting of the fiber rope if needed, so that we couldn't continue testing with it. So, but it's nice to see that they got it going afterwards. So there are other ways of cutting also, and this is a kind that probably would have worked on the chain that we were trying, the mantis, it's called actually. I was assured that it's not a praying mantis, so the insect. It's a mantis shrimp that it's been named for, which is a whole nother thing. It's a really cool animal. So it can kill crabs with one blow. So it can basically punch them and they die. So it shatters their shell, and it uses cavitation to do it. So that's really cool. Basically, it uses cavitation principle for shattering the shells of crabs. So if a crab comes over to where it has its nest inside some rocks, then it's going to just punch it, and it goes really quick. You need to have those slow motion cameras in order to capture the punch. Basically, it has a punching arm which is levered with tendons, so that it's sort of it's got a shoulder joint, and it's got an elbow joint. Then it's got sort of the club part on the end there, and with the tendons and everything going through here, it's sort of storing up quite a lot of energy, and it releases that energy when it does the punch. So basically, it's not punching like we do with our muscles. It's basically just relaxing instead, so that this arm just flies out and punches whatever it is that's in the way. So it's going to fly out in a really large speed. So the speed is enormous, and once it hits something, it already has cavitation bubbles that it's pushing in front of it. So it's actually the cavitation bubbles that hits the shell of the crab. And those cavitation bubbles burst and release huge amounts of energy, and then the crab is dead. So it's a really cool animal. So just YouTube it, mantis shrimp. See, there's quite a lot of different channels that have done slow motion clips of them to see it. So they're really cool. So that's why it's named mantis. It's not because of the praying mantis, but because of the mantis shrimp. But this diamond wire cutting tool, that would have worked on the chain that we couldn't cut with the mantis. And that's because it doesn't have any blade in here. So it doesn't have this blade part going. It just has basically a chain with loads of diamonds on it, cutting diamonds. So, in case anyone didn't know that, those are industrially produced diamonds. It's not diamonds from a diamond mine. So it's industrially produced, and they're not really worth anything much other than their cutting value. so they're not beautiful to look at or anything like that. They're just very sharp and very hard. So that's the whole point with them. So even though it sounds very luxurious to have a diamond wire, it's not really. So what this one does is it rotates a loop of diamond wire around here, and it's also able to push this string of diamond wire. So it starts off in here and it pushes it forward, and then it's going to cut into whatever it is it's supposed to cut. So we have a very nice clip here from a different supplier. Basically uses the same principle as in the mantis saw, with just two claws that are holding onto the pipe. So that's also a very nice principle of cutting that can be used subsea. The difference between this one and the mantis saw was that this one usually needs to have a constant connection to the hydraulic supply, which basically means that you have to connect it to the hydraulic supply before you lower it into the sea. So they usually don't have those hot stabs, which we had on our saw, and they are usually also quite a bit larger. So they are more difficult to maneuver, and are a bit more of a hassle to get connected to your hydraulics when you're going to use them. So that was what they ended up with in the operation, where we had the mantis saw for the fiber rope. In case that was going to be a failure also with the fiber rope, then they had one of these on board as well. To be able to mount on the anchor chain and cut for that one. So that was like the fourth or fifth step of redundancy in being able to emergency release this rig that they were anchoring up. So it's pretty amazing how far they actually think sometimes when they are doing stuff like this. So, but the diamond wire cutter is often used, especially in situations where you are decommissioning offshore rigs and stuff like that, where you need to actually remove and dismantle and remove a rig that's out of use, where you can't get any more out of that field. Then usually most countries have laws in place that say that you can't just leave it out there to rust and fall apart. You have to remove the rig. You can't just leave it. and that's where these really come into effect, these large diamond wire cutters, where they can start basically just cutting larger structures up into smaller pieces, and then they can tow them away with the vessels. So, but they are used sometimes in construction parts also, especially if it's a modification operation where you're going to modify an already existing structure, whether it is on the ocean floor or if it's just a submerged part of another structure. It might be necessary to cut away parts of the existing structure in order to fit in the new structure. So that's other ways they can be used. Then we have torque tools. We've already discussed a bit with regards to the work ROVs that they can't attach a nut to a threaded rod or a bolt. So they really don't have that fine-tuning of their finger skills on the manipulators. So it's pretty difficult to manage an operation like that. But they can tighten and loosen bolts. And when they are tightening and loosening bolts, they are usually using a torque tool like this. How this one works is that you have a receptacle part, and this one is placed over the nut. So the nut will basically be hidden inside the receptacle there. And then you have the tool itself, which the ROV brings over. So the back part here is where the hydraulic motor and all of the control systems are. It connects to the hydraulic power supply of the ROV. The ROV holds it in this handle, and then you can connect regular pipes on here to match the nut size that you have inside the receptacle. Then the ROV inserts the torque tool, this part of the torque tool, into the receptacle. And it's a bit difficult to see them here, but you can see best on that side. There's a bit of a ridge there, and there's also one here. And those will enter into these slots, which means that the torque tool is locked into place with regards to rotation, so it can rotate anyway. And then when they get this one across the nut, then they can start running the hydraulic motor inside there. So they're going to start loosening or tightening the nuts with regards to whatever direction they're running their hydraulic motor. So that's a really nice tool for opening and closing different tools when they're using it. So there are quite a lot of use of these, especially for assembly of different kinds of equipment subsea. So you have like for the we looked at the hot tap project where they were basically clamping on a lot of equipment onto a pipeline, where they were going to weld a new piece of pipe onto to make an intersection in the pipeline. So when they were clamping that part, they used a torque tool to tighten those nuts for the clamp. So there's a lot of uses like that for them. And now we have the hot stab. So the same. It's a different supplier than the one we used on the Mantis when I was designing there, but it's the same. This part here is the same one because it goes from an API standard. So American Petroleum Institute, one of their standards, tells how the male and female parts of the hot stab is supposed to look, while the part up here for the handle and the connections to the ROV hydraulic power supply, those are basically free for design for whichever company is creating these. But it's supposed to be in such a manner that even though we had hot stabs from a company named Blue Logic, and this one is from Oceaneering, I believe, you could still do the male part from this one, and you could stab it into the female receptacle on the Mantis, and it would still work. So that's the whole point with having those API standards, is that you can cross them like that. So we have a small clip here of an ROV that is using a hot stab. So this is a different design again, but it's still a hot stab. So you can see the hydraulic line going into it. And here he can't actually see where he's going to put it in, because this one on this one it's the female part is on the ROV, while the male part was on whatever structure it is that he's connecting it to. So he can't even actually see; he just knows that there's a receptacle there. So I'm just going to try to make it fit. so it's but that's how one of the ways that you can do it. You don't necessarily need to have the female part on your equipment and the male part on your ROV. You can have it the other way around also. So it just made sense for our the Mantis tool that we were creating. It made sense to have the female part, because then you didn't have to have any tubing connected to the male parts there. So that was that clip. So here we have different cleaning equipment that can be used with an ROV. So basically, we have a tool with a rotating disc. So it's a hydraulic motor that's rotating a disc here, and then you can. These are different brush tools that can be placed on there. And this one, I'm not quite sure, but I think it is solidified citric acid, so that it's basically lemon juice made solid. So they've basically been boiling it until they are left with just the acidic particles of it, getting all of the moisture out of it, and then they create different kinds of shapes in order to do cleaning, because then you can put solidified citric acid into water, and it's going to start dissolving into the water, and you create acid in that localized area around that lump of citric. And then especially if you start rotating it also, and you get this rubbing motion on it, it's going to create even more acid. So basically what you're achieving with that one, if you are putting it on a rotating machine like that and you are pressing it to a surface while it's rotating, you are creating an acid wash. So you're basically washing the surface with acid. So it's a very, very effective way of cleaning a surface. So even though it's subsea, you can have a lot of cleaning done that way. Let's see, that's a bit better. So this is another Norwegian company, a very small one, but they have created these handle parts. So they are trying to use just two handles for use, and then they have different kinds of these solid citric inserts that they can put on the handles. And they are going to fit into different kinds of equipment. So depending on diameters and shapes of these citric parts, they're going to be able to fit them inside of different kinds of openings in equipment, so that they can basically clean them, especially in areas where you have a lot of marine growth. Then you can get that cleaned away with acid wash like this. So it's a very, very nice cleaning tool to use. So let's see if there was something. Here you can see a proper assembly drawing. So they have quite a large parts list and loads of parts in there. And you can also see they have a very different title block from the ISO one that we're working with in our CAD. And basically, all companies have different setups for their drawings. But all of them are still following the ISO standard with regards to what information is shown. They're just not following the ISO standard with the format of how it's supposed to look down there. Because of course they want their logo in there, and they might even want extra information that isn't a part of the ISO standard often. So like in the ISO standard, there is nothing that tells the weight of the part that you're creating. So I know at least in Emenco there is one of these areas give the weight of the parts, just so that you have it there. You don't need to put in a parts list in order to show what mass the part has. So there are many different ways of doing these, but all in all, you'll always recognize an assembly drawing or a part drawing when you are looking at them. So even though people are using different setups, you can still recognize what it is. So here you see a couple of images of how the handles and the citric stuff look. So then I think this was the last one, was it? Oh, there was one more. Yeah, this is actually a drilling tool for use by ROV. So it has in the middle here, there is a drilling tool being run by a hydraulic motor, and it can slide up and down so that you can start drilling into the surface of what it is you're drilling. And it actually has 3 suction cups to keep it in place. So that if you want to drill a hole in the side of a large metal plate in a structure, basically where if this is just a huge flat plate, where are you going to get your equipment locked into place or anchored while you are doing the drilling? So then they've actually used suction cups instead. They might have used the magnets, would also have worked, but magnets can be a bit tricky with regards to electricity, short circuits, and also if you use magnets on a steel surface, and it has electronic equipment inside it that's going to run, then your magnetic field can start interrupting the workflow of the electronic equipment inside. So it might not be that smart to use it. While as the suction cups, all you need to do is to be able to suck a vacuum in here. So it doesn't necessarily need to be an air vacuum. It can be a water vacuum also, that you are basically just sucking water out of the suction cup. So it still works on the water just as well as it works on land with suction cups. So it's a nice way of getting a tool to work like that, and you can put it straight on a flat surface. That was the last frame, yeah. So then we'll continue next week. This was the last subsea technology for this week. The one